options provides data on options ordered together for a particular model of automobile. Consider the following rules. So, rule 1, if faster engine, then traction control. All right, so that's first one. And then I'm gonna put rule 2 kind of further down. Rule 2. Oh, is somebody saying something? No? Okay. I thought I heard something. Okay. So if faster engine, then, oh, wait, if faster engine and 16-inch wheels. Okay, then 3-year. Okay. So we have our rules. And this is the, give me 1 second. So this is the antecedent, consequent. I'm sorry if any words are spelled incorrectly. That's just how it's going to have to be on these. Okay, so we have our rules. I'm going to try to gauge where you guys are with this question. What are our first steps, or what do we do first? And for this question, we're trying to find confidence, support, and lift.
First, I calculated the totals for each of the columns.
That sounds like a good plan. So let's do that. So equals 2, the sum, shift control down, enter, and we're going to apply it to every column. No need to lock anything. All right, so we have our totals, and we'll just keep in mind that our total number of records, or let's not call them records, total number of cars is 50. So we're going to need that number later. Okay. So, and then I have, let me pull up a formula that's pretty intuitive for you guys. Support, lift, formulas, images. Okay, so this one I found to be really helpful. So to find support, we want to find the frequency of, so let's define the terms. X in this case is if faster engine, and Y in this case is traction control. Is this, can everyone see this, or is it too small?
Can see.
You can see it? Okay. So to find support, we find the frequency of X and Y. So the amount of cars we see with a faster engine and traction control. And we put that over the total number of records, or total number of cars. So support equals to sum product. Now this is the formula our professor had told us to do. I was trying to find a way to do this easily. So this was how he did it. So I think it's the best way to do it. So we do the sum product of the two of these. So fastest engine and traction control. And let's take away these totals because it's going to mess up our numbers. Sum product. And let's put that whole formula in parentheses as our numerator, divided by the total number of records, which is 50. I keep calling them records, so we're just going to call them records. All right. And that gives you 20%. So there's 20% support for this rule. So out of all the cars, if you create this rule, there's about 20% of them that fit that criteria. Okay. Then for confidence, let's go ahead to our formula again. So confidence is the amount of times you see the rule divided by the amount of times you just see the first part of the rule. So if faster engine. So equals to sum product of fastest engine. And again, got to take away the sum, comma, traction control. Bring that up. And put the whole thing in parentheses as our numerator, divided by just the sum. Well, so it's the amount of times we see that. So yeah, it would be the sum of fastest engine. Which we could have just put 22 as well, but I just did that.
Is it 22 or 12 that you divided by?
So it should be the sum of all of these. Did you get 12?
Yeah, I got 12 too.
You got 12 too?
It's for fastest engine, not faster. That's probably why.
Yeah.
Okay, so you got 12 for fastest engine. All right,
I don't remember hearing the professor say that in
okay,
class.
these words are a little tricky. I see what you mean. So let me fix that on my end. So it's not faster engine, it's fastest engine. So I'll change that to C and this one to C. And then this one I'll also change to C and C. Okay, so let's check it. It is the sum product of fastest engine and traction control divided by the sum of fastest engine. So that's the amount of times we see that in the data set. Okay, and turn that into a percentage. Okay.
Do you have to write the cell or could you just write 12?
So, I mean, there's a couple ways you could do it. You could do the sum of this. You can manually click on 12 here. Or you can just put in the number 12 also. Any one of the three works. So what confidence is telling you is that this, this rule shows up more, okay, it's like the percent that you would see this rule show up in comparison to the amount of times you'd see just the first part show up. So it's like a ratio between the two. So if there is a faster engine, let me think of a simple way to explain this. So if fast engine, then traction control. And okay, so it's comparing the amount of times you'd see just the antecedent or the faster engine to the amount of times you will see the entire rule. So the higher the confidence, it means that like with a higher confidence, it means that you'll see the entire rule much more than you'd see just if faster engine with some other characteristic. So higher confidence means that you see them together usually, and that means your rule is correct. But if you have lower confidence, that means that there's a lot of times where you'll likely see just faster engine with other characteristics that doesn't link it to traction control. You see what I mean? So if there's a high confidence, there's a high association between the two. So if you guys want to look at what I'm looking at, I'm on page 371 of the textbook, but it looks like what I was doing before was support over expected support, which it looks like there might be two different types of lift. This one in your textbook is asking for confidence over expected confidence. So it's a little bit different, but it's very similar. We're going to be using the confidence instead of the support. Sorry. So that was my mistake, but it's a different formula, and then I can explain it a little bit more. So the confidence, we're going to use that as the numerator instead of support. And then it's going to be divided by the expected confidence, which is just the number of the consequent. So 33 divided by the total. So 50. So whereas the other formula, we used support as a numerator, and then we use both of them. We're just doing the confidence, and then we're doing the consequent support. I did this because based on the example in your textbook, that's how they calculated lift. I think we should go with that one. So, boom. And that is not a pretty number there. Okay. So let's turn that into a value. Okay. So it says that lift provides information about the increase in the probability of the then statement given the if part. So given that there's a faster engine, what's the probability that we'd see traction control? And like I said, the textbook is kind of funny about the formula. So in the textbook, it says that the confidence for an example question is 8. So it's supposed to be a number, a whole number. And the higher the lift, the more likely you are to see the consequent given the antecedent. Okay. So that's the explanation for that. You guys have any questions? Okay.
You said the higher the lift, the what was that?
The higher the lift, the more likely you'll see the consequent given the antecedent. Or in context, the more likely you'll see traction control given that the car has a faster engine.
More likely we would see the what?
So the higher the lift,
Yeah, I
the
got
more likely you'll see traction control given the faster engine.
Okay, gotcha.
All right, I'm gonna leave this one for you guys, but I can just say that when you're doing the and statement, you add them together. So you add up the two sum products in the numerator.
You said when we're doing the and statement,
Say that again?
when we're doing the and statement, we add them together.
Yes.
Okay.
So I'll just calculate the support so you guys can see, but the confidence will be somewhat the same. So equals to sum product of, okay. So faster engine. So we can do all three of them in this one. So faster engine, 16-inch wheels, and 3-year warranty. all divided by 50. Hold on a second. If faster engine and, oh, I didn't change these. Okay. All right. And so that would be your support. So I did the sum product, including all three of the characteristics. And the same would apply for lift. You just do the sum product of all three. So do you guys, I'm just feeling the group vibe. Do you want to go over another question? Do you have any specific questions? Or do you guys feel confident about the homework?
I just stepped away for a second. My issue with question 12 was rule 2, since there's now 3
Okay,
variables.
I can share my screen again. I just showed a little bit of that.
Oh, sorry.
So, no, it's fine. So for the support, I used all three within the sum product function. Okay, and then for the confidence, remember that formula is the frequency of the entire rule over the frequency of just the first part. So you would do the sum product using all three of them over the sum product of just the first part. So that would be faster engine and 16-inch wheels.
Okay, got it.
Yep, and then lift, same concept, confidence on top, and then you'll have just the X value. Yeah, just the sum of the Y value, sorry.
Okay,
Mhm.
thank you.
So I pose the question again. Does anybody have any additional questions,